Yeah. Here is the abrasive disc which cuts the camshaft blank here, and up here there is a pattern which is 4 times the size of the cam blank. These two are coupled on with a timing belt on a 1-to-1, so 1 revolution here equals exactly 1 revolution here on the blank. The reasoning for that is that the blank will follow exactly the profile as presented by the the cam profile on the top. The cam sits on a shaft which is pivoted here, which is allowed to move backwards and forwards, and here is the abrasive disc which acts upon the cam blank. The wheel here presses against the cam at all times and is held onto the cam by this spring, which is part of the chassis. As you rotate the cam, the whole of this bell crank, if you like, moves out and in as it follows the profile, which gives us the final result here. Once the cam has been cut to dimension, the abrasive disc assembly is moved to cut the next profile. Hi, what we're going to do is create a camshaft using this device here. What this is basically a cam follower. There's a pattern cam at this end that is 4 times greater dimensions than the finished dimension of the cam here, and based on that, from this point here, which we'll call the pivot, from the pattern cam is 4, and the cam rotates at position 1. This will give the camshaft a copy of this cam at a divisor of 4, if you like. So what we're going to do is we're going to fit this into here, and then we're going to look at the plan and make sure that we get all these profiles right. This camshaft will belong in a engine boxer 4-cylinder, and there'll be 8 profiles to cut. These profiles are very close to one another, and the wheel I'm using is a 10mm wide wheel, which is just enough to undercut without impacting the profile next to it, the cam. Here is the completed camshaft. It is as per the drawing, and there are 8 lobes, and they've been cut as designed in this drawing here. Thanks very much for watching.